In the last video, we took a look at this ANOVA test briefly and kind of the motivation behind why we might need it. Now, as I state here below this definition, unfortunately the idea behind an ANOVA test and exactly how it works is fairly complex. It's not impossible to understand, it's just a little bit time consuming, and so we won't actually be going into much of the reasoning behind how this particular test works, but we will be able to at least compare a lot of what we will do in this section to things we've done in previous sections. So let's take a look here at the general overview of the test to note some of the things that are similar and some of the things that are different. You'll see that at the start here, we're going to start, just like we always do, with our hypotheses. We're going to set up our hypotheses, and these are the ways that they're pretty much always going to be written down. H0, our null hypothesis, is going to be that all of the different averages I'm looking at, no matter how many of them there are, that they're all going to be equal to each other. And H1 is going to say that, and this is important, at least one of those means is different from the others. Maybe mean number 2 is the one that's different, or maybe they're all different, but at least one of them is going to be different. So those are my hypotheses. When I go ahead and I get to my test statistic and I start to list out my sample evidence and check conditions, I can see that when I go ahead and list my givens, that's really going to be taking my data and just entering it into different lists in my calculator. For conditions, I have a couple of conditions that are here to check. We'll talk about those when we get into a specific example. And we're going to go ahead and compute a test statistic. We're not going to talk about a formula to create this value, but it's going to be notated by this letter F. It's going to be an F score that we have for the problem. It's going to kind of take the place of the Z's and the T's that we've been looking at recently. Now, on our calculator, we're going to be using an ANOVA test, and I'll show you how to do this in the next video. But we're going to have to insert all of our lists offset by commas. Now we're going to draw an F distribution, which actually almost looks like an exponential distribution, except that it kind of has this hump at the start instead of just moving over to the side. Remember that all of our continuous distributions have different shapes. We saw things like uniform, exponential, normal. We've talked about a t distribution already. And so this new distribution, this F distribution, is going to look something like this. And one interesting thing about every single F distribution, and the way that we're going to use it in the ANOVA test, is that it will always be a right-tailed test. We're always going to have some value of our F score listed down here, and we're always going to shade to the right. Every time. There's nothing to worry about here with two-tailed tests, or if it's left-tailed or right-tailed, nothing like that at all. It's actually really nice. And then we'll go ahead and state our conclusions in the same way that we always do. So hopefully this makes you feel at least a little bit confident that there's not too much that's different here from what we've done in previous sections and types of hypothesis tests. In the next video, we'll take a look at example 1 to see exactly how we can go ahead and utilize all this information in answering our first ANOVA hypothesis test.